Hello friends, welcome to BISP Solutions. BISP Solutions is a tech company and provide technological solutions across the world. And myself Ashwin, and I welcome you in our today's bootcamp. Now, in our last bootcamp, we have seen what is PyTorch. We have seen the introduction to PyTorch. Then we saw the introduction to PyTorch tensors, right? So these are some basic things that we need to understand before going forward, right? Similarly, today I am going to show you linear regression. Exactly, linear regression means exactly what? Linear regression is a technique used for prediction, right? Now prediction means what type of prediction we are talking about. So prediction means, for example, let's take a daily life example. If a boy is asking to his parents that I want to take mathematics in 11th standard, but based on his past performance, he achieved like 40% in 9th standard. He achieved 50% in 10th standard. So based on this, what parents will say, okay, don't take mathematics as your main subject, take something else. So that is called the prediction. Based on previous performance, we predict what will be the next output, right? Similarly, if we say that like I am having the data of sales order, right? Sales data, that last 5 years whatever the company has done the sale. Now what will be the next output within the next 2-3 years? So based on that we extract the prediction. So that is called prediction, and for this linear regression technique is used, right? So this is how linear regression technique is used. For example, let me give you one more example. For the last 5 years, suppose I am living in one state, that is Madhya Pradesh. So now suppose for the last 5 years there has been very high temperature in summer season, right? So and I am having a plant of cold drink plant. Now within the last 5 years my company has done so many sales in this field, right? Cold drink selling. Now based on that, what will be the next output? So based on that, first I will get the prediction on summer, right? How much temperature will go high, and based on that the profit will be calculated. So that is called prediction. So based on past data we do the prediction for the next few years, because in previously when this regression techniques and prediction techniques were not available, what company used to do? The company used to just take action and then whatever, either profit or loss the company. But today we are having those techniques so that we can take correct necessary decisions. We can avoid the wrong decisions, right? So that is why these linear regression techniques are used. And since from here only, these are the parts of machine learning, right? These are some parts of machine learning, exactly how machine can help a company to achieve greater profit. Okay, now see here, first of all I will explain you exactly the introduction to machine learning. See here, machine learning is a subset of artificial intelligence. That's it. Now in machine learning, linear regression is one technique. There are almost so many techniques in machine learning, right? But here we are focusing on linear regression, and linear regression works on numerical data. We have to provide the numerical data. Now why I am saying this, that numerical data is used, you will come to know in within few minutes, right? Okay, so now see here, introduction to linear regression. Now what is this linear regression? Now linear regression means it is applicable on two types of variables. One is the dependent variable and another is the independent variable. Now dependent variable and independent variable means what? For example, profit and summer temperature, that is the temperature goes high, so profit is dependent on this summer season temperature. The temperature, whatever we provide the temperature series, based on that we can calculate, okay, this much high, 50 degree, above 50 degrees Celsius the temperature is going, that means our profit will be more because maximum sale will be done. So these are called dependent variable, and that is called independent variable. Now if you see here, this is a picture form of this linear regression. Linear regression gives a straight line relationship between two variables, that's it. Now here you can see independent variable and the dependent variable. If the independent variable increase, dependent variable will also be increase on the same proportion. Now if you see this straight line means line of regression, and this data points, these are the data. So this straight line will be drawn with the help of regression technique, correct? Let's move ahead. Now see here, simple linear regression and multiple linear regression, right? So here if you see here, simple linear regression, I have explained you. Simple linear regression means this is M, X and C. C means coefficient, M means the one is the dependent variable, and X is the another variable. Similarly, in multiple linear regression, you can see here there is a one more coefficient, then the slope, and then the dependent variable, that is the Y. So same thing I will explain you in technical point, right? Technical point of view. Now if you see here regression equation, whenever a regression equation is applied, you can see here Y means dependent variable, X is independent. Now X is independent and Y is dependent. Similarly, as I said, sale is Y, that is the dependent variable, and summer season list, temperature list, that is the independent variable, that is called X. And based on that, the slope M is derived coefficient of the line. So in this way we extract the prediction, right? This thing will be clear to you in few minutes. Okay, so now see here steps of code, right? When we will see it practically, everything will be clear to you. Okay, now steps for code. Now if you see here, data, now data get data set following a linear relationship. Now see, data means exactly what? Data means, suppose there is a coating plant factory, and I am the manager. So what I will do, I will get the data. Now data means exactly the sales data. Basically it's a sales data. Just take any example, sales data. Now sales data means item name, the country name where it is sold, right? Then what is the profit, what items are sold, and then what is the price of that item, and how much profit that we gain. Now profit, this will be taken into Y variable, and remaining everything will be taken into the X variable, right? So this is how we put. Then second point is split data. This is what I was telling you. Split data means divides the data set into training and testing sets. Now splits data, 80% data, that is the training, and 20% data will be dedicated to train. Now what is this train and test? See, 80% data we use for training. So first of all we train the data, and then we put that data into the testing part, right? Now the train model means what? Uses linear regression from sklearn to fit the model. Yes, first of all we train the data, then we fit that data into the linear regression model, and then that model extract the prediction, right? Look at this, predicts output for test data. Then evaluate model, MSE and mean square error, and R square to measure accuracy. Then whatever the data is extracted as a part of like prediction, now we measure the accuracy of that data, then plot the regression line. Finally the managers or the higher authority, they are habitual of seeing the graphs, so we have to plot that data ultimately, right? So this is how the complete process takes place. Now I have explained you in the format of PPT, right? Now let's go to the next part, that is the practical. Now see here, I have done this already, but for you better explanation I will do it again. So first of all, I will create a new interactive Python. See here, IPyNup, that is IPY, interactive Python kernel, right? So linear regression bootcamp, right? I will just put the name here first, linear regression. It will take a little time, 1 or 2 seconds. After that it will work. Yeah, so let's linear regression bootcamp, right? And then I will rename it. Fine. Now first of all, see, Python language is the base, and this is supported by Python, right? So each and everything, whether if you talk about PyTorch or the data science, everything is supported by Python, right? So that is why this Python language is most powerful, and it supports all these regression techniques and machine learning techniques, everything. Okay, so now let's come to the point here. Suppose first of all, what we will do here, import, I will explain you one by one everything, right? Now look at this. Now see here, import pandas as PD. Very first point, that is import pandas as PD. Pandas is a library that is used to do the calculation, or we can say the whatever the data science library does, right? So manipulation on data, extracting insights of the data, everything. Then import numpy as np, numpy, number, num, that is a number, it comes from number, so mathematical calculation is done here. Then import math, that means mathematical library. And then pyplot means whatever we have done, we have to plot each and everything. So that's why now I will hit the enter button. That means everything is imported, right? You can see here the asterisk sign, it is currently working. Look at this. So okay, now it's done. Okay, now what the next is here, just now see here what I have done. Let me explain you first. Financial data. Now financial data, see here, let's suppose, assume that I have the financial data of a company, of the company, the financial, that is the transactional data of the sales order, right? And I have saved it into the financial data. Same thing I have imported. Now see here, this is the technique to read the CSV using pandas library. So while working on this PyTorch and linear regression examples, you have to take care of this, how there is a list of commands, right? Pandas library having a containing a list of commands, so you can easily search it. Now see here, this is the location that we have to put here, and fin data, that is the financial data. Now see here, everything comes. Now if you see here, segment, country, item name. Right now I have given you a few minutes back, I gave the example of cold drink, right? Here you can take any data. Right now this is the original data that I have taken, and now here you see this is what the item price, the profit, the month number, everything. But the thing is that this linear regression works on numerical data only, right? So numerical data, how it will do? So first of all, because what happens here, alphabets does not work, right? Now see here, fin underscore data pd dot get dummies, then fin data. Now if you see here, everything is converted into number. Look at this. right? Fin data, get dummies, so everything is converted into number. Okay, now let me explain you this also. Now look at this. Now this data you see here, if I show you government for 1 and remaining here you see enterprise for 0. Similarly, if you see here country United States, here you see 1, wherever United States. Now this data is extended here. Look at this, total 435, total 435, but they have changed it to different countries, right? Suppose if I go item name peso, everything here you can see, we can't see here the whole data, but yeah, it is expanded. This table is expanded because it used the numerical value in place of every word, right? Now as I have shown you that one is dependent and one is independent, right? So X is independent and Y is dependent. Now why Y is dependent? In the very starting of this boot camp, what I have shown you, like summer season temperature list is a independent variable. It is not dependent on anything, but based on that temperature list profit can be calculated. So profit is an dependent variable. Same thing here we have done. X is a independent variable, Y is dependent variable. Now what we have done, we have separated the data. Look at this, separated the data. Look, right? Now look at this, everything is separated and this is our Y, that is the profit. Okay, now what will be our next step? So let's see this. Now see here, from sklearn model selection, okay, selection, train, test. Now exactly what is this train and test? As I have explained you in the beginning here, if I show you what is train test, here is train model, right? Now this train model means, see, machine learning concept based on first the machine will train itself and then it will test. Same thing is here, we train the data. For example, the machine that cleans the dust from a room, right? So for initially that machine, we start the machine and then machine will take the measurement of the room. It trains itself. If any hurdle comes in the middle, what we have to do. So after the training, then it will start working on. Same thing is here. First of all, we have to train the data, and for this 20% data is for 80% is data is for training purpose and remaining 20% for test purpose. And this random state, why? Because the data should not shuffle, right? Data every time, if the data changed, then our purpose will be lost, right? Yeah, that is why this random state equal to 51 is written, so that the data will not be changed. Once the data is set, then it will be forever, right? It will not change frequently. Now this you can see here the asterisk sign, so currently it is working. Let's wait for 2-3 seconds. Look at this, the data has come here 88%, right? 88 and 20, it has divided, right? So 80% is 348 here, 20% is, that is 88, and in this way the data is now divided. Now what will be our next step is, from sklearn, let me copy this here. Now see here, from sklearn linear model import linear regression. Now linear regression is a complete function in itself, right? So we have to import that linear regression here, right? So now how we will do, just write down this, from sklearn.linear model import linear regression, right? We can you can easily find the commands on the net. but here we have done it here like this, import linear regression. So linear regression is a function. Now lr variable we have taken, lr dot fit. Now see, lr dot fit, that means x train and y train. First of all, we will fit the data. Where is that x train and x test? See here, x train, x test, y train, y test. That means the train and test and of both x and y, that means the train and test of both testing data and training data, both, right? We have taken here lr dot fit. Then lr dot score means that is the, we are talking about that mean square error, right? And after that we have to fit this data. Now see here, 77% accuracy is derived, right? That is called accuracy. So we have derived that accuracy. Now what will be the next? Now see here, y prediction. Now y prediction, lr dot predict x test. Now if you see here somewhere, lr dot predict. Okay. Now we have taken lr dot predict x test. So whatever the x test data, that means the after training, whatever the data that is remaining in x test, then we have to take into the y pred, that is the prediction, and then actual value, that is y test, right? And predicted value, that is y pred, and difference is y test minus y pred. That means whatever the difference, that is tested data minus the predicted data, and predicted df, data frame, right? So let's enter this. Now look at this, actual value is this, predicted value is this, and the difference is this. There is lots of difference, right, in the difference part, right? Now, so what, that is why it has shown here the 77% accuracy, right? After that, Seaborn library is used for plotting the data. You can plot any type of data with the help of this Seaborn library, like just like sklearn, scikit-learn library, pandas library. This is one of them, right? Seaborn library is used for showing the data. Okay, now import Seaborn dot Seaborn as SNS. Okay, now SNS dot rig plot x equal to y test, y equal to y pred. That means y test and y pred, that is the dependent variable, y test and y pred. Now we have we have the tested data also, and we have the prediction data also, right? And scatter it into blue and red color. Okay, so with the help of this blue and red color, what you will see, let's wait. Yes, now look at this. Now what will happen here, if you see, just a second. Okay, now if you see here, this blue color dots, they are the actual data, and this red color dot is a predicted line. Now this line, that is why it shows a clear cut plain line, right? The straight line. That is why it is called as straight line regression also. Now what happened, this line and the dots, if they are close to each other, that means this prediction technique, that is the linear regression prediction technique, is much better. And suppose if it is far away, if the dots are far away from these lines, so what will happen, it is considered to be as a inappropriate or unsuitable prediction technique, right? So this is how it works. Now if you see here you see 77%, Why this 77% accuracy? Because this, you can see here, these two dots are far away from this red light, right? Then this red color line, and then this blue color dots. Okay, so in this way, if you see, this linear regression work. Now this linear regression technique can be applied on any type of data wherever it is required. We have to take care of this. It does not mean that anywhere you can apply it. We have to see the scenario exactly, how what they are trying to predict or what they are trying to extract. For example, as I already give the example of cold drink plant, right? You can take any example. For example, just say how much like let's take a grain like rice. How much rice will be sold within the next 2 years? So that depends on the locality, what type of people consumes there. If you go to sell the rice in south, you will get a profit. If you go and sell that into the north, when majority population they consume the wheat, right? So in this way, linear regression is derived based on two variables. One is the independent variable and another is the dependent variable, right? Independent and dependent, these two things are there. So if you understand the relation between, or the connection between, or the dependency between these two variables, we can extract anything. We can do the prediction on any type of data. For example, let me give you one example. Prediction means exactly, suppose government is thinking to open a shopping mall in a city, but how they will predict? So these things can be predicted with some data. For example, if I say that in that particular city there are so many colleges, IT colleges. Now where there is IT college, that means there might, and if I say that there are so many IT companies, startup company as well as the big giant companies are there. So based on that, when there are IT company, definitely there are IT professionals, and when there are IT professionals, definitely the spending capacity of the citizens will be increased. And in this way, the government or the businessmen, they come to a conclusion that okay, we shall open a shopping mall in that particular city. Similarly, if let me give you one more example on this prediction, right? Prediction, the dependent and the independent variable. For example, the government is trying to start a local train project, right? Local train, or we can say metro rail project in a city. So how they will predict that metro line project is successful in this particular city or not? So they will analyze the how much tickets are sold in bus, or how much rush is there in the bus. So based on this analysis, that how much tickets, how much revenue is generated in bus system, right? So how much revenue is generated in bus system, that is called the independent variable. And dependent variable means what is the chances of success. So in this way, we take one variable as an independent variable, one variable is the dependent variable. Based on the past few years percentage, parents take the decision that you can take this subject that is suitable for you. So this is how the prediction process takes place, right? So let's have a quick recap here. Today we have seen the linear regression technique of machine learning. Now tomorrow we will see the linear regression in PyTorch also, right? Today I have shown you that is it's a part of machine learning, right? Machine learning. So tomorrow I will explain you about this, how it is done in PyTorch. So before that, let's have a quick recap, and I also recommend you to watch this video one more time to get better clarity, right? Because to understand something, we need to watch it again and again. Okay, so let's have a quick recap. Import pandas as PD. Panda is a library that works on what we say, cleansing and massaging the data, right? Second, numpy used for numerical calculation, so that's why we use numpy. Then third is pyplot means plotting the data, right? Similarly, financial data, first of all we need to extract the financial data. Now financial data in a company, there are so many data, right? Bulk of data, but we don't need each and everything. We need few columns of those data, right? For example, segment, country, item name, because this linear regression technique is capable enough to predict taking even if we provide less amount of data, right? But the data should be relevant. Okay, now you can see here the profit and the item name and the revenue and the item price, total revenue, right? This is the profit. So we now this is sufficient data, total 436 rows, right? So we have worked on it. Then fin data, financial data equal to pd.getDummies. GetDummies is the function, is the property that we have used here. And what this getDummies do, it converts every alphabetical value into the numerical value, right? And it expands the column of the Excel sheet, or we can say the CSV file. That is the data frame. Okay, now you can see here all these things. Now first of all, just a second, get dummies fin data. Okay, now x equal to financial data. So what we have done here, we have taken only those variables which are those columns which are necessary. So financial data equal to this first, right? And then financial data profit. So why is the financial data profit? So profit part is not visible here in this section. You will never see the profit part, right? Now after that, item name, not item name. So we have taken here x and y. After this, x and y, financial data, profit, x and y we have extracted here. And then what we have done here, scikit-learn model, train test. Now train test function is used to, suppose we are having data. Now we have divided into two, x that is the independent variable, y is the dependent variable. After that, x train test, y train test, right? Now we have splitted the data into two parts, that is the 80% for training purpose, 20% for testing purpose. And then random state 51 means data should not shuffle. Okay, after that, if you see here, from sklearn linear model, import linear regression. Now here the role of linear regression comes. After that what will happen here, if you see LR fit, LR score, so we have to fit the data into linear regression function, right? Then it has given you 77% accuracy. Now how we can increase this accuracy, I will show you in our next bootcamp video, that is tomorrow. So don't forget to attend that bootcamp. Okay, now y prediction is this actual, predicted and difference. We have taken out this actual and predicted. You can see here there is a difference, and there is a much difference here, right? And based on this data, what we have done, we have imported the seaborn library, and based with the help of that seaborn library, we have plotted the data. And this is how it was plotted. It's a straight line regression, right? And I have shown you that these dots are far away from this line. That is why it has given you the 77% accuracy. If the plotted line, or we can say the dotted dots, whatever the dots are, that is the actual data. If it is very much close to that predicted line, that means this regression technique is suitably fit for this particular data, right? So guys, in our next video, what we will do, I will show you the PyTorch regression technique, right? Regression technique is in PyTorch also, so we will see the linear regression in PyTorch. And I recommend you to watch this video again, and then you will if you face any difficulty in understanding it, you can write down in the comment box. I will help you in that, right? We will have a separate session of question and answer, right? And guys, those who are new, I know that today also few guys might be new for this channel, so please subscribe my channel, right? Okay, see you tomorrow in our next upcoming bootcamp, right? Thank you guys. Thanks for attending the bootcamp.